Welcome to our comprehensive discussion on the unique methodologies required to evaluate modern artificial intelligence systems. This is part 30 of our AI Audit Exam Prep series. In this session, we will explore how to document system specifications, identify and eliminate hidden biases, and rigorously test defenses against sophisticated cyber attacks. As a risk professional, mastering these evaluation strategies is entirely practical for your daily career. You will be able to confidently advise your executive board on whether a new automated customer service tool is safe to deploy, or if it secretly harbors liabilities that could damage your company's reputation. Understanding these specific testing frameworks allows you to bridge the gap between technical engineering teams and corporate governance. The first major concept we must understand is the model card. To explain this simply, a model card acts exactly like the nutritional label on the back of a food package or a detailed appliance manual. Instead of listing calories and ingredients, it lists the structural blueprint of the artificial intelligence, which we call its architecture, along with the specific datasets used to teach it. It explicitly states how well the system scored during testing, known as performance metrics, and strictly defines the scenarios where the system should absolutely never be used. By having this transparent label, organizations can build highly targeted test cases to uncover the system's exact weaknesses and establish strict operational guidelines. This builds immense trust and transparency between the developers and the end users. However, you must remember that while standard templates for these documents exist, they are rarely perfect out of the box. An organization must carefully adapt and customize these templates to ensure all critical, company-specific risks are properly documented. Next, we turn our attention to bias testing. Traditional software is tested to see if the underlying mathematical logic is broken, but artificial intelligence is different because it inherits the flaws and prejudices of the data it consumes. If a system learns from skewed information, it will produce wildly inaccurate results, harmful outputs, or completely fabricated answers, which the industry refers to as hallucinations. These prejudices can take many forms, heavily favouring or discriminating against certain age groups, genders, races, cultures, or religions. To catch these issues, auditors look for data balancing, which is a process of analysing the input information to ensure all demographics are fairly and equally represented. The most effective strategy here is adopting a shift left mentality. Shifting left simply means moving your testing activities as early in the project timeline as possible. Think of it like cooking a massive pot of soup. If you taste the ingredients and filter out bad spices while you are chopping vegetables, which is the data cleansing and pre-processing stage, it costs you almost nothing. But if you wait until the soup is fully cooked to realise it tastes terrible, you have to throw the whole pot away. By detecting prejudices early, companies avoid the massive financial cost of having to completely retrain a broken system. If a system has already been trained and biases are found, testers must repeatedly run test scenarios, scrub the data, and force the system to relearn until fairness goals are finally met. Let us now examine how we protect these systems through adversarial testing. Adversarial testing is essentially a digital stress test. It involves a team of authorized experts, often called a red team or ethical hackers, who intentionally feed confusing, malicious, or toxic data into the system. Their goal is to trick the system into making a mistake, proving whether it can withstand attacks from real criminals or survive highly unusual, extreme scenarios known as edge cases. To thoroughly understand these threats, the MITRE Corporation built a comprehensive encyclopedia of attack methods called the Adversarial Threat Landscape for Artificial Intelligence Systems, or ATLAS. As an auditor, you must understand all 14 tactical stages a criminal might use within this framework. First is reconnaissance, where attackers quietly gather intelligence by reading public research, hunting for known vulnerabilities, scanning the victim's websites, and snooping through application repositories. Second is resource development, where they actively build their weapons by acquiring machine learning tools, establishing infrastructure, and crafting poisoned datasets. Third is initial access, where they break through the front door by compromising the supply chain, stealing valid passwords, exploiting public applications, tricking the system with prompt injections, or using traditional phishing scams. Fourth is model access, where they actually get their hands on the system via physical entry, software interfaces called APIs, or by intercepting the system's thought process. Fifth is execution, where they force the system to run their malicious commands, often by compromising external plugins or manipulating user actions. Sixth is persistence, where the attackers plant deep roots to stay hidden long-term, using hidden backdoors, deeply poisoned training data, or self-replicating prompts. Seventh is privilege escalation, where the attacker upgrades their own security clearance by breaking the system's rules, a technique known as jailbreaking. Eighth is defense evasion, where the attacker uses clever prompts and model tricks to actively hide their malicious behavior from security monitors. Ninth is credential access, which simply involves hunting down and stealing unsecured digital keys and passwords. 10th is discovery, where the attacker maps out the system's internal brain, figuring out its logic family, extracting its foundational instructions, and studying its hallucinations to find blind spots. 11th is collection, where they gather up sensitive local data and system artifacts. 12th is the staging attack, where the criminal builds a safe, hidden proxy model to practice and perfect their crafted attack data before launching it for real. 13th is exfiltration, where the attacker quietly smuggles the stolen data out of the company via cyber leaks or inference queries. Finally, the 14th stage is impact, where the ultimate damage occurs, ranging from shutting down the service, spamming the system with garbage data, destroying the integrity of the database, or causing massive financial and external harm to the enterprise. This brings us to the rapidly expanding threat landscape surrounding modern systems. Recent breakthroughs in generative artificial intelligence have created systems that can interact through multiple modalities. A modality simply means a way of communicating, such as typing a text prompt, speaking a voice command, or holding up a visual sign to a camera. Every new way a system can communicate opens up a brand new threat vector, which is just a technical term for an attack pathway. Think of a bank vault that only had one heavy metal door. It was easy to guard. But now, that vault has added a drive-through window, a mail slot, and a rooftop helicopter pad. It is much more useful, but infinitely harder to secure. Throughout the 2000s and 10s, corporate use of these automated tools hovered safely between 20 and 30%. However, since 2023, adoption has skyrocketed past 70%. Because companies are rushing to implement this technology so quickly, their security guidelines remain highly immature. This massive, poorly protected market has attracted highly sophisticated cybercriminals eager to exploit these exact vulnerabilities. Let us recap the crucial points we have covered today. We established that specification documents act as a blueprint for safe operational boundaries. We discussed why it is vital to test for demographic fairness early in the data pipeline to avoid catastrophic retraining costs. We explored how ethical hackers stress test these boundaries, and we meticulously walked through the 14 distinct phases of a cyber attack using the industry-standard threat matrix. Finally, we highlighted how the explosion of multimodal technology since 2023 has drastically widened the vulnerabilities facing modern enterprises. To ensure you have fully mastered these vital audit frameworks and threat models for your certification, please head over to RooCloud.com. All of the concepts, matrices, and testing strategies we discussed today are thoroughly covered in our practice tests. We highly recommend solving these chapter-wise multiple-choice questions right now to lock in your understanding before proceeding to the next lesson in the curriculum. Thank you for watching, and I will see you in the next session.